Hi everybody, welcome to another Java session. Quite excited to take you now to the next step of Java. So, we start with learning about identifiers. Everything in this world, every entity in this world is named. It is the same concept that we use in Java. Whenever you declare variables, whenever you declare methods, we saw an example of method during introduction. Whenever you introduce a class, a package, anything in Java is actually named. And these things that we name is what we call identifiers. Every time you refer to anything in Java, you refer it using a name. When you refer to a method, when you refer to a class, we're going to see what variables are. When you refer to variables, all these, they are referred by names that are given unto them. And there are specific rules that must be followed for you to be able to write these identifiers. Failure to use the rule. Java is very strict when it comes to its rule. Failure to use the rules, normally an error is thrown. Number one is all identifiers use letters, digits, underscore, and $sign only. So you cannot have an identifier with an ampersand. You cannot have an identifier with a bracket. You cannot have an identifier with a plus. The only things that you can use to write an identifier are letters, digits, underscore, and $sign. Number two, any identifier can only start with a letter, an underscore, or $sign. It cannot start with a digit. So you cannot have something like, if I take an example of an identifier called num. So num1, this is very okay. But you cannot have one num. It cannot start with a digit. But instead of this one, you can start with an underscore. You can start with a $sign. This is very acceptable, but you cannot do this. But this one is very acceptable. This one is very acceptable. This one is very acceptable, but you cannot start any identifier with a digit. You can never use reserved word. During introduction to Java, we worked very close and saw what reserved words are. And just a recap, they normally appear in blue. And these reserved words have specific meaning to the compiler. So you cannot use reserved word as your identifiers. And finally, identifiers can be of any length. So you can have the longest identifiers that you can. Now, when we're talking about identifiers, we said they used to name things you refer to in a program. For example, variables. So what are these that you're calling variables? Variables are normally used to store data in a program. And normally variables are what you as a developer declare. So think about when you want to compute the area of a circle, what do? You need an input of a radius. So you can have a variable that you call radius. Remember to use the rules that we have learned of identifier to name the radius. The radius, and when you say the radius is equals to 7, what has happened? Normally in variables, this equals is not equal sign. We call it an assignment operator. An assignment operator. What you're doing, you're actually assigning number 7 to a variable named 7. We're not trying to say radius is equals to 7. No. This we are saying assign the number 7 to the variable called radius. When you talk of computing the area of a circle, we can have it as pi times 7 times 7. What you're saying, once you're done computing the pi, once you're done computing the area, store it in a variable that you're calling area of a circle. Again, I can have a variable called sum. Sum is equals to 3 plus 3. Now, when you're naming a variable. Simply what you're saying, once you're done adding, assign the answer to it to a variable that is called name. That is why we say variable are used to store data in programs. And the ones that use here is an equals is not an equal sign, but we call this an assignment operator. When you're naming your variables, one key thing that you need to do, they need to be descriptive. Descriptive. By descriptive, this is what I mean. Somebody else might say S is equals to 3 plus 3. When you're referring to S later in your code, you might not understand what S means because it's not descriptive. You do not know whether S is summation. You do not know whether S is multiplication or what S refers to. So when you're making your variables, make sure they are descriptive. When you say radius, we understand all of us what radius is. When you say area of a circle, you understand the area. If you are looking for a perimeter, we can talk of a perimeter of a square. This is a descriptive, and you can say its length times width. Okay, when you talk of length, we know what length, and you can even have the length of a table. Remember, one of the rule is it can be of any length, so you can have when you're practicing, ensure that your variables are descriptive. They describe the kind of task that you want that variable to handle. Now, after you've known the rules and you've known what variables are, now there's something we call data types. Data types simply tells the type of value a variable is holding and the type of operation that is going to be that can be undertaken. I repeat again, a data type, it tells the type of value a variable is holding, and also the type of operation that can be done. So there are two sets. I normally give them as two sets. Reason being, there are different operations that happens within the two sets. So we have the numerical data types. The numerical data types are 6, depending on the type or the number of range a number can hold. When you talk of a byte, remember, when you're declaring numerical data type, the beginning, all the letters, the starters letter are small letters. So a byte is any number that is ranging between -128 to +128. So when I'm declaring a numerical data type byte, I can say byte num1 is equals to 100. 100 is within the range -128 to +128. So byte, again, this is small letters. Again, we have short. Short comes between, the range is -32,768 to +32,767. So when I'm declaring short, I can have short num1 is equals to something like -5,000. You realize -5,000 is within the short range. Then we have integer. Integer, again, you have to compute -2 to the power 31 to +2 to the power 31 minus 1. So when you're declaring again, we can say int num1, 1,000,000 is within the range, 10,000 is within the range, 100,000 is within the range of integer. So again, this is a small I. Be very keen because Java is case sensitive. Capital I here changes the whole statement here. So again, integer is within that, and we have long, which is actually can hold the largest number in terms of integers. Integers have no decimal points. All these byte, short, integer, and long have no decimal point at all. So when you're declaring long, it's declared a little bit different from the rest. So we do long, say num1 again, I can have 15 million. That is a long 15 billion. That is a long number, but now has to end with a letter L. When you're declaring long again, unlike the rest, we are not adding anything after here. It's just the normal semicolon as you're doing the statement. But when you're declaring a long, you have to end it with an L. That is the syntax. Then we have the decimal points. For decimal points, there are two data types, the float and the double. The difference is float can hold up to 7 decimal points, and double is a float double precision, which means it can hold double what float holds. That is 15 decimal points. When you're declaring float again, there is a little twist to it. So we say float num1 is equals to 1.23, end it with an F. That is to show that is a float. It is a syntax. But for double, you don't need to add anything. You simply declare double num1. Num1 is equals to 1.23. So these two, they are the same but different data types. So that is all when it comes to numerical data types. Most of the ones that I love using is integer. I'll be using integer when it comes to integer and double. When I'm using numbers without decimal, I like using integer. When using the numbers that with decimal point, I like using double. Reason being, sometimes you might forget initializing it with an F, which might give you a small error. Then we have the character data type. Character data types are two, and normally string is a combination of character. Now, how do we declare characters? Character is equals, if I have character C is equals to single quotes, put your character there. Has to be 1. So you cannot have a character as CE. Immediately you have it as 2, then that is a string, because these are 2 characters. So character, you can declare another one and have maybe A and have capital A. Those are 2 different characters. A, capital A, and small a. If I have small a, those are 2 different characters. So this is how you initialize your character. And string, we're going to talk about string in details, but when you're declaring a string, remember you to start with a capital S. A string, if we have name is equals to, when I'm declaring double quotes, we have string name, we have double quotes, and you have the name Nancy. So if you look at Nancy, this is a combination of 1, 2, 3, 4, 5 or 5 characters. So string is a combination of characters. And those are the 2 types of characters that we have. Finally, we look at the numeric operations. Remember our numericals here, we are talking of byte, short, integer, long, float, and double. So what are the numeric operations that you can do? The normal addition, 1 plus 1 equals 2, 2 plus 3 equals 4. So you can do addition to your numerical operation. The normal subtraction that you know, 58 minus 1 is equals to 57. We can do multiplication. The sign for multiplication here is asterisk. So we can have 3 asterisk 3 is equals to 9. We can have the normal division. 1 divided by 2 is equals to 0.5. So these are thus the normal numerical operations that you know in any mathematics. Now the most interesting here is what we call a modulus, and some books calls it remainder. What happens? It gives the answer that you give is the remainder after the division. What am I saying? 20 modulus 3. I'm saying 20 divided by 3. It is 8. It is 8, yes. Is it 8? 6 times 3 is equals to 18. So 18 minus 20 minus 18 is 2. So 20 modulus 3. The remainder here is 2, which simply means 20 modulus 2 is equals to what? If you divide by 2 is 10, remainder 0. All right. If we can take another one, 6 modulus 3. If you divide 6 by 3, it is 2, remainder 0 again. But again, the 6 modulus 5. If you divide 6 by 5, you have it as 1 again. The remainder here is 1. This is the work of a modulus. If you do 20 again, modulus 3, the remainder after you've divided 3 is what you give as an answer. What is an example of using a modulus? Think about a question where you are to differentiate between the odd and the even number. I'm going to leave you that for you to think about it. How do you use a modulus to be able to differentiate between a number that is even and that is odd? In case you finish this series, kindly put the answer in the comment section, but you're also going to use it quite often in our Java program. So thank you once again. Like and subscribe and share, but most of all, remember to learn. Thank you.